Hello, my name is Gerald Lopez from Contemporary Biology 1233, and today I'm going to talk about how to make a scientific experiment using the scientific method. So before we get in depth about talking about how to make a scientific experiment, we have to understand what the scientific method is. So a scientific method is basically a process of examination and discovery of natural phenomena that involves making observations, constructing hypotheses, testing predictions, experimenting, and drawing conclusions and revising them if it's absolutely necessary. In order to create a scientific experiment, you have to have the mind of a scientist. And by thinking like a scientist, you begin to make observations about the world, noting apparent patterns or cause and effect relationships. For example, you're sitting outside on a sunny day. It's pretty windy outside. You notice the tall green grass moving along with the wind. And at some point, you begin to feel a little bit of itchiness in your nose. Throughout whatever the wind is blowing onto your nose, you begin to sneeze. You look back at the grass that's being moved by the wind, and you wonder, how come the grass doesn't sneeze? How come all plants don't sneeze? If they're able to absorb air, how come they don't sneeze? That is your observation. The next part in our experiment is the hypothesis. The hypothesis is a proposed explanation for an observed phenomenon. In other words, this is the starting point for further investigation of your experiment. In order to make a hypothesis acceptable, it has to have two things. One, it has to be able to explain with great detail about an observed phenomenon. Number two, it has to be testable with different experiments. So let's go back to my plant example. We understand that both humans and plants absorb gases. For example, humans absorb oxygen, plants absorb carbon dioxide. So the hypothesis would be, if we were to use the same gases and material that make humans sneeze, then it should make the plant sneeze. Prediction, based on the scientific method, is a statement or an estimate that a certain event will happen in the future or the consequence of a previous event. So prediction is important because it is one of the two factors that make a hypothesis acceptable. An example of prediction is our plant example. We know that black pepper will make a person sneeze, or maybe a tickle to the nose with a feather will make a person sneeze, or we have a foul scent from a foot that will make a person sneeze. Our prediction will be, if we were to sprinkle black pepper, tickle a plant with a feather, or maybe stick our foot next to the plant will sneeze. Critical experimentation is important because it makes it possible to determine whether a particular hypothesis is correct. So, in our example, we are going to sprinkle black pepper, tickle the leaf of a plant with a feather, or sticking our foot next to the plant to see if it'll sneeze. After the test results, you can come down to your conclusion. You can also make a revision in your experimentation by creating a new hypothesis and test that hypothesis to strengthen your confidence in that hypothesis with strong evidence. Unfortunately, in our case, we've tried putting our foot against the plant, sprinkle black pepper, and tickle the plant with a feather, but it seems that all three have failed to make the plant sneeze. Therefore, our conclusion for this example is that plants do not sneeze.